Hello, everyone, and welcome to Need for Speed. My name is Stefano, and I will be your host for today's panel. I'd like to begin by gratefully acknowledging that Science World is located on the traditional and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh nations. I encourage you to be curious and explore the nations on which you may be doing your STEAM research or experiences. We'll start today with a quick introduction for our amazing mentors, and we've got a great, amazing group with us today, followed by a hosted discussion. If you have any questions for the mentors, please do feel free to put those in the chat at any time. Any questions, any comments, any curiosities, please feel free to put them in the chat throughout the presentation. Our technician today is me. So if you have any tech issues, I can be there to support as well. I do ask that you keep comments in the chat and questions respectful and relevant to the topics being discussed, of course. Now, it's about time we meet our fantastic mentors. Let's start by going around and doing a brief introduction before we jump into questions. Let's bring them on stage. Welcome to Hillary.
Hi.
Welcome to Erica.
Hello.
And welcome to Stephanie.
Hi.
I'd love to get to know each of you, a little bit of an introduction, and we can let our audience know who you are, a little bit of what you do, and that should get us rolling pretty quickly. So Hillary, why don't you start us off?
Cool. Hi, everyone. My name is Hillary. Really excited to be here today. I am an aerodynamicist with the Mercedes-AMG Petronas Formula One team. And what that means is I work on designing and determining what shape the surfaces of our Formula One cars should be. And I think one of the coolest parts of my job is being able to see something that started off as an idea in your head and seeing it out on track, racing at very high speeds and competing for world championships. I think that's quite exciting and cool, fun.
Very cool. Yes, that is an exciting thing. How about we go to Erica next?
Hi everyone, my name is Erica and I'm a fifth-year mechanical engineering student in Toronto. And I'm currently the team captain of Ryerson Formula Racing, which is our student design team in the FSAE, or Formula Society of Automotive Engineers competition. And I am a research assistant in renewable energy. So one of the favorite parts of the stuff I'm working in is getting to help propel renewable energy and see how it's going to affect the future.
Very cool. Renewable energy hopefully will draw some questions. I'm sure I have some myself. Stephanie, I feel like you're dying to tell us a little bit about what you do and your title and exciting things about your career.
For sure. No, I love this. This group is great. My name is Stephanie, and I am an aerospace engineer, more specifically spacecraft engineering. I spent most of my work on designing, doing kind of systems engineering overall, integrating all of the different pieces together for satellite spacecraft, and the Dragon spacecraft was the big one that I did when I worked at SpaceX for 8 years. So I really enjoyed working at SpaceX from the very beginning when we were a tiny company that hadn't launched anything into orbit, up until getting to regularly launch things up to the International Space Station, which was really exciting because we were the first commercial company to do that.
Wow. Some great stuff. I am excited to hear more about each of your careers and journeys and some stuff. Now, I'm going to start with a simple question. What is the coolest thing you get to do in your day-to-day or as your job? You can choose. I'm going to reverse engineer this and go to Stephanie.
Sure. Well, one of the things that I really loved about being at SpaceX was that the engineers and the offices were all in the same building as the factory. So you could just go out on the factory floor and walk around, and it was something new every day. It was because in the same building, they were building rocket bodies, they were building engines, they were the electronics, thrusters, everything. And all kinds of cool tests. I remember one day going out and, they were welding the domes for the tanks and sparks flying everywhere. And you just never know what you're going to see. And I love that things are just fast paced and it's a great environment.
That sounds amazing. I have a hunch that Hillary, as a aerodynamicist, has some similar stories. Do you?
Yeah, I think one thing that's quite cool about being an aerodynamicist is you're working with something that is kind of invisible in our day-to-day life, right? You can't see what the airflow looks like. And what's quite cool about being an aerodynamicist is we have all these tools, whether it's simulations in computers or being able to go to a wind tunnel and do these physical tests, but you start to get an idea of what the flow field looks like, which I think is quite powerful and really interesting, because you can then find ways to manipulate it to get it to do what you want, which is quite cool. I think one of the not so day-to-day cool things is at the end of the 2020 season, for the last race, the team surprised us all with a special livery where they put every single person's name on the team on the cars as they went around the last race of the season. And that was such a special kind of moment to see, how many people contributed to making this possible. And was such a great way to end the year.
Amazing. Erica, I bet you've got some cool stuff to share.
Yeah, I kind of have two different things going on. So similar to Hillary, I work on race cars, but on a smaller scale. So, which she also did in university. So we got to build race cars, which is incredibly cool in university with your friends when you're studying, when you're trying to learn engineering for the first time. So that's a really cool part of what I do in school. I get to work with many different engineering programs like electrical, computer, biomedical, aerodynamics, and mechanical to build something very integrated, very multi-system, and then go to see your work race on the track and try to be good in competitions. On the renewable energy side, I get to work on actual experiments. So a lot of engineering research is more theoretical and more simulations in computer, whereas the project I'm working on has an experimental component. So I get to directly see how my work is affecting the characteristics and the change of a system, and then see how we can improve it and implement it into other areas of renewable energy.
Amazing. Very cool, especially given the fact that your perspective includes being still in school and looking forward. Do you have any questions, Erica, or do you have any ideas or thoughts that you have for Hillary and Stephanie? Because you're sort of not at the Girls in STEAM 14 to 16-year-old level, of course, but you're definitely not at the experience level that Stephanie brings to this session.
Yeah, both these incredible women are essentially who I look up to as well. So I'm almost in the same boat as, the 14 to 16-year-old girls watching here. The only difference is, I've had some experience or some awareness of what they've worked on and know how incredible it is to work on those projects. So I'd say my first question maybe to Hillary is, how did your experience in undergrad working on a design team like the one I'm on relate to your experience in Formula One? And how would you say getting involved in general can prepare you for a career in STEM or engineering?
Yeah, that's a great question. I think being involved in FSAE was a huge part of what I did during my undergrad. And I actually didn't know that I had wanted to work in motorsport until I, started doing FSAE and realized, oh my God, this can be like very challenging and very interesting, and just learning how much work basically and how much development goes into a Formula One car. I think FSAE and any engineering student team really is such a great experience, because not only do you get a chance to work on a project and kind of apply what you learn in class or any research you do on your own time into making something physical and testing your knowledge, and thinking, like, is what I think right? Is this true? And kind of do experiential learning that way. But I think it's also great because you work with a group of people, like you said, from a diverse range of backgrounds in a bunch of different fields. And I think that's super applicable in F1 because, you're also working in this really tight-knit team environment, and being able to work with other people is such an important skill to have. And I think it's really been, a great experience to have in undergrad leading to work.
I completely agree. Also, to build off on that, you mentioned that like Formula One, like FSE and university, you're working with a very diverse group of people. I think for me too, similar to you with FSE, working with a diverse group of people helped me figure out what engineering I wanted to be in. I actually originally came to university for chemical engineering and didn't really know much about the different engineerings that were out there. And then working on this team, working in an environment where you're constantly challenged with people who work in different fields, kind of helped me guide and learn what skills do I actually want to learn? Where do I want to be in my career, and what program I want to be in? So that's another advantage to design teams as well, too. You can help figure out where you want to go.
Mm-hmm. Yeah.
I feel like that help figure out where you want to go is a perfect last few words to transition us into that question. I mean, there's going to be all kinds of folks out there interested in how to get to where you are right now. So maybe if we can each take a sec or two to discuss the journey of getting to where you are and some advice maybe for a 14-year-old STEAM future leader.
Do you want me
That's
to
I'm going to go to
Sure.
Stephanie. She had
Yeah,
the last
yeah.
word, so I'm going to start with you.
I can jump in. So yeah, I mean, there's first of all, there's no right path. And your path is going to take a lot of twists and turns, no matter what. I don't think I've really heard any standard path. So some people, at your age are gonna know what you're doing or think you know what you're doing, and sometimes it stays the same, sometimes it changes. In my case, I knew I was really interested in space flight and space exploration back when I was in high school. Actually, before that, I thought I wanted to be an astronaut, and that kind of evolved into becoming an engineer. And really enjoyed physics and math, and it's like this all kind of seemed to point toward engineering. So I got my undergraduate degree in mechanical engineering, and then actually took a few years off before going to graduate school. I was very lucky that as an athlete, I was invited to train for the U.S. national team for rowing, and so I took a couple years off to do that. That's my big twist and turn. And then I went to graduate school, got my master's in aerospace. And from that point on, it was all career and working as an engineer at a few different aerospace companies. I worked at Lockheed Martin. This is all in California, by the way. I'm originally from the U.S. So yeah, this is then after Lockheed Martin, moving to SpaceX, and after SpaceX, moving to Millennium. One thing that I really noticed early in my career was, one, getting hands-on hardware experience was super valuable, and I'm sure Hillary and Erica would agree with that with their jobs as well. The best way to learn how something really works and how it fails is to be hands-on. And they talk about test often, fail often, and that's really a good way to move forward. And really took that to heart, especially during my time at SpaceX. We weren't afraid to test big and fail big, whereas other companies, the more kind of traditional way was like, "Oh, that testing costs a lot of money. Maybe we should analyze some more," that kind of thing. And but definitely appreciate the testing and getting your hands dirty. Even though I went in as a spacecraft systems engineer, a good piece of advice that I got early on was to do some test engineering. And I did that at the system level, which was really great for understanding how all the pieces work together, and how one engineer might design one thing and it works great, at a unit level, at that component that maybe it's a gyro or something like that, one piece of it that works well, but then once you've incorporated it into the rest of the system, you need to make sure that you can talk to the flight computer and you can store your data and you can do all these things. So I really enjoyed those system level problems. I'm getting a little bit off track of the career path here, but that's kind of why I went the way that I went with my career path, is because I really wanted to get into all these different areas and how they're all connected together. So I could do the mechanical, the electrical, the propulsion, the mission operations, everything. So there we go. I'll let you guys move on.
It sounds like you were very much led by your own curiosity, and you saw the different things, then followed those paths along the way. So that's good advice generally, I believe. I'm going to get to Erica and Hillary with that question about that career path, starting from curiosity at a younger age, and to current present time. But I'm going to focus it with a question we've got on the chat from Sukmani Chahal, and they want to know, what universities can you attend that lead you into Formula One? So if Hillary, you can take that question, give it us a bit of an answer, and help flesh out that previous question.
Cool. Yeah. I think one advice I would give for wanting to get into Formula One is just making sure that, you know, your fundamentals of like the physics and the maths are really, really solid. And you can get that education at a lot of different universities around the world. So I did my undergrad at the University of British Columbia. Honestly, when I was in high school, didn't know that I had wanted to be in engineering. Like I think up until 11th or 12th grade, I was like, I'm going to apply for engineering, I'm going to apply for English, and I'm going to apply for fashion design, which are so different. But once I got to university and started discovering what engineering really was, and being a part of the Formula SAE team, I kind of became super interested in that and knew that that was what I wanted to work towards. So, you know, for an aerodynamicist specifically, it would be making sure, you know, you have a good understanding of, say, undergraduate level aerospace engineering concepts, or doing a lot of fluids courses if you're in like a mechanical engineering major. After I'd finished my undergrad, I actually came to the UK and did a master's in race car aerodynamics specifically. But I don't think that is required. I think because you're working on kind of coming up with a lot of creative ideas, the most important thing is to have a solid kind of understanding of the physics behind it, which then allows you to be creative and like come up with ideas to achieve what you want. And I think what Stephanie mentioned about test often, fail often is something that really resonates with me because I think the aerodynamics of an F1 car is so complicated that, you know, I think there's a YouTube video of someone asking our technical director how many ideas fail trying to improve the aerodynamics of the car, and the answer is a lot. So having that kind of ability to go to the wind tunnel really often and kind of test your theories is so valuable because, you know, you might leave a wind tunnel session thinking all of my brilliant ideas didn't work, but and that might be a little bit demoralizing in the moment. But ultimately that kind of creates much, I guess, that creates the opportunity to learn, right? Like, so why was I wrong? What were the blind spots, and where can I go forward from there? But yeah, just to come back to the original question, I think any good aerospace or mechanical engineering program with a focus on fluid dynamics would be a good place to start. But also, I think the advice I would give is, if you're interested in something or if you're curious about a topic, just, you know, get started and, you know, start learning on yourself, whether that's, you know, finding a book or doing a personal project like buying a little Arduino and start doing programming or whatever. I think that's a great place to start and to kind of just get started on your own without waiting for someone to teach it to you.
That's wonderful. That's wonderful. A lot of great stuff so far in this panel. I'm very enthused, and I hope our viewers are enjoying the answer to these questions. Erica, I'm not going to miss asking you about the journey and path to get to where you are and maybe where you're going. So please feel free to jump in with that. And of course, I bet that the three of you probably have some questions for each other. So after that answer, we're going to try to see where that leads us. If, of course, the audience watching doesn't throw anything in the chat, we're just going to ask our own questions. But feel free, viewers, to put those questions in the chat. As you can see, we like to answer them. So Erica, what about your journey?
Perfect. So similar to Hillary, I did not know I wanted to do engineering until very late in high school. I actually decided in the first semester in October of my grade 12 year, which is very late because applications start, I think, in Ontario in like November-ish. And I actually attended the Ontario University Fair where I talked to a female engineering student from Queen's University and kind of heard her experience. I had always liked math and science, but I never really knew where I could apply it to. I wanted an exciting and a creative job. But engineering and STEM weren't really like super common in my childhood or in my high school. So I kind of didn't really know it existed really until grade 12. And once I talked to that female engineering student, I decided, okay, this is what I want to do. but I didn't have any of the courses I needed to do it. So in order to attend University for Engineering, you need 2 out of 3 science courses, which include chemistry, biology, and physics. And I only had chemistry at that point. So I ended up taking both grade 11 and both biology and physics grade 11 in my first semester of grade 12, which was a lot of courses for being in grade 12 in high school, just to make up the prerequisites that I needed to actually apply to the program. So definitely similar to what Hillary kind of mentioned, being curious early and being exposed to these topics early and just wanting to learn something, anything early will definitely help you figure some of this stuff out, but also just teach you some really cool skills. I really, really, really wish I started learning anything about engineering or coding or modeling or even just building things in high school. I think it would have opened me up to so many opportunities and helped me decide what I wanted to do earlier. Even when I applied to engineering, I still didn't really know what engineering was. And I originally applied for chemical engineering because I like chemistry. And that really was my only foundation into what engineering could be. And then once I got to university, when I joined our Formula SAE team, I learned what the different engineerings were. And I learned what mechanical engineers did, which have a lot to do with moving parts and analyzing and simulating parts on how they work and how they fit together, and solving a lot of problems both Hillary and Stephanie worked on in their careers and today. So that really interested me. And in the mechanical engineering environment, I was constantly learning something new, especially working on a race car. I had never dreamed of working on cars or doing anything like that. So it was really eye-opening and really interesting. And from my experience with my Formula SAE team, I've learned a lot of technical and interpersonal skills. And that kind of led me to opportunities in research, where I now work as a research assistant in renewable energy. And that's kind of where my future is going. I want to do a master's in renewable energy technologies, either currently continuing the investigation that I'm doing right now with geothermal energy, or finding somewhere else where I can work to better implement renewable energy sources right now into current infrastructure in cities and try to make us 100% green or 100% on renewable energy.
Very cool. Like I said, I'm going to open it up for some questions because I have a bunch, but I feel like they're also going to be much more specific if you all ask them. But maybe take a quick pause here and go, where are you all joining us from today? I'll go with Hillary first.
I'm joining from England, so it's 7 p.m.-ish here right now. Mercedes, the F1 team, is based in England. Yeah.
Cool. And Erica?
I'm in Toronto.
Toronto, yeah. And so the time is a little earlier than
2:30.
There you go. And Stephanie?
And I'm in North Vancouver.
So time zone is 11:30 in Pacific. Wonderful. That's same as myself. And the reason I asked that too is also just to kind of put in place the places that we are right now, but also the places you may have come from. So maybe where did you grow up or do some of your studies? Maybe naming a couple cities, and we'll just go with in the same order. Hillary?
Cool. Yeah. So I grew up in Richmond, very close to Science World. Did elementary school there, high school there. Have lots of fond memories of visiting Science World as a kid. It was very fun. Definitely sparked my curiosity. I did my undergrad in Vancouver, then moved to the UK for my master's and have been here since.
Erica?
Yeah, so I did elementary school and high school in Vaughan, which is just outside of Toronto, and now I'm doing my undergrad at Ryerson University in downtown Toronto.
And where would you like to end up?
I don't know. I really wanted to end up in the UK. Not necessarily for Formula One, but I have a deep love for the UK, so that's somewhere I hope to get to work one day.
Maybe we've sparked a connection here today. That's great. Stephanie, how about yourself?
Yeah. As I mentioned, I grew up in California. I went to Princeton for my undergraduate, and then jumped around a little bit with the rowing back to California and Georgia and Boston, Massachusetts, and then ended up getting my master's at Stanford back in California, and then work kind of kept me in California for a while. That's also where I met my husband, who's Canadian, which explains how I ended up here in Vancouver. So
Wonderful.
it's good.
Awesome. Thanks for putting that in there. We do have another question from our chat. So do hold on to your questions for each other, but I'd like to get to the questions from our viewer here. So before you get into Formula One or any other similar racing, what type of qualifications do you actually need is the question. I believe this would probably be aimed at Hillary, but maybe Erica could speak to some of this as well.
Cool. Yeah, I think it kind of depends on the role that you want to get into. So I think one of the misconceptions is that a Formula One team is just the people that you see on TV at the track. But in reality, there's like hundreds of people back in kind of the headquarters in the factory, and there's a ton of different roles. So depending on the kind of role that you want to go into, there's different qualifications required. For an aerodynamicist, which is an engineering role, typically you would need a bachelor's in an engineering field or a science field. And that's kind of similar for any of the engineering roles. So if you want to be a mechanical engineer in a Formula One team or a composites engineer. So bachelor's in engineering, I think, is the requirement. A number of people do have masters or PhDs, but those aren't kind of explicitly required. If that makes sense.
Erica, do you have anything to add, or does that sound like a pretty great answer?
Yeah, actually, I was just going to add, it was a great answer, but just to add as well. So definitely in terms of physical qualifications, the degree, and then similar to what we've both done, a design team like Formula SAE really opens you up to experience or similar or a lot of skills you would use in Formula One. But I'd also say, just to bring it up, there's a lot of local teams per se that aren't Formula One. It's really big in the States, but there's also some in Canada that do some version of racing. So it's not necessarily Formula One, but maybe vehicle racing or different teams like that. A few of my friends on my Formula SAE team have joined race teams, and that's a good way to kind of get other skills similar to kind of testing skills and just team skills that F1 may look for. So there's that kind of stepping stone where you can be in a different type of racing locally to see if Formula One is something you want to do or to gain the skills for it.
Cool. And I just quite curious, Stephanie, though you don't work in Formula One, your vehicles move quite quickly as well. And you did mention about testing and field testing.
Even faster.
Yeah, I'd say. Did you want to add to that piece of the conversation?
Well, one thing I actually wanted to say is that SpaceX recruits alumni of Formula SAE.
It's all tied up in a nice bow.
It's a huge badge of honor. I mean, if you've done that, then you understand like how to work in that environment, and so I've got huge respect for the Formula SAE for sure. Yeah.
I have a feeling all three of you would have a great time hanging out together over a coffee. I'm glad you're all here. That leads me to my next point is if any of you have questions for each other that our audience viewers would like to hear where your curiosities lie. And of course, still opening it up to the chat if you want to put any questions in. Please do ask. We have about 10 minutes left, and we'd love to hear questions from you. But let's see where the curiosity lies with these fantastic engineers in our panel.
I do have a question. Thanks. So Stephanie, SpaceX is, big name. I think lots of people kind of dream of working at SpaceX, and you guys have done so many cool things. I'm curious to hear what was either the favorite project you worked on or kind of the achievement that you're most proud of during your time there.
Oh, thanks. Yeah, the absolutely, like my favorite moment was the first time that Dragon connected to the International Space Station. I mean, it was a huge, I was probably in tears when it actually happened. When I first arrived at SpaceX, I think the company had 200 people. Most of them were working on Falcon 1, which was our little baby rocket that we started with. And there were 12 of us working on Dragon. We had just gotten this kind of little development contract from NASA to work on this. They were looking for commercial alternatives, and the space shuttle we knew was going to be retiring. This is back in 2006, 2007. And then to go from that like small team and a design that was mostly on paper to actually having it fly up to the International Space Station and have the astronauts from the space station open the hatch and like climb in and check it out was just amazing. So that was definitely my favorite. I always call Dragon like my one of my babies. I've got 2 other babies who are human, but Dragon is one of my babies.
So cool.
That's so cool.
That's insane. I was going to ask for Stephanie as well. For people who want to get into the space industry, maybe not necessarily education, but that as well, what other skills would you encourage them to look into or start to learn early?
Really? Well, I would say there's so much happening right now, especially in what some people call new space or commercial space. It's kind of the way that the industry has changed. There's this kind of ecosystem, all these little new companies, and I would definitely encourage people to follow what's going on with all these new companies. There's new rocket companies and other related companies, and so besides your education, your degree, definitely stay informed. It's a kind of a fast changing environment, so there's a lot of different opportunities changing all the time. I would for sure go for internships, and like we talked about earlier, these kind of hands-on opportunities. Sometimes you make your own opportunities too. I mean, I've done some volunteering work both at Science World and at science fairs and things like that, and I'm always amazed at students at these science fairs who have created things that could be experiments that fly in space. And I mean, these are things that taking the initiative is like really valuable. If you can come up with an idea, I think teamwork is super valuable, as you guys have obviously experienced. That's such a big part of the job. It's such a beautiful thing when you've got, whether it's, 3 people or 100 people, but everybody kind of working together, sharing information. The favorite people I worked with are the ones who want to be teachers as well. And so I think you can kind of aspire to become that, it's like you learn it all and then you pass it on. I think that's kind of a good attribute to go for.
Very cool. I for sure encourage that that notion of sharing the knowledge and mentoring. Is why you're here today. That's fantastic. I feel like learning it all and then passing it on. That's a pretty big feat, learning it all. I think learning a little bit at a time might be okay.
Many small bites.
The idea too that you have a teamwork is very important. I know scientists can sometimes feel like you're studying solo. I'm not sure if any of you have experienced that, where you're really in your one space doing your one thing, but then the idea that the community and the teamwork and the grouping and the connections are super important as well. So not to get caught up in that is, I think, something I've heard and more than once before in these kinds of sessions. I would love, is there any other, I've got a question. I've got some time, and if you still have more, don't worry. I'd just like to know, and I think our viewers would be kind of curious, what is it can be brief, what is a day in the life of each of you like? Who would like, Erica, would you like to start?
Sure. So like I said, I'm still a student, so I go to school downtown. So I'll wake up, take the subway, go downtown. A lot of my lectures are in the movie theaters in downtown Toronto, which is kind of funny. So I get to have lectures in a movie theater. And then after class, I will go work in our workshop for our Formula SAE team. So whether it be working with power tools or welding or building the car or taking something apart or testing it. We're also building an electric vehicle this year, so we're doing a lot of electrical testing. So I'll work on that throughout the day. And then at some point, I will do my research work as well, which is very coding heavy. So I get to do more online stuff, planning experiments, coding. And then, come home eventually, eat, and do it all again the next day.
Very cool. More than I had expected in a day. Very busy and exciting day. Hillary, how about you?
Cool. Yeah. So for me, it kind of a day-to-day kind of thing depends on where we are in the design cycle. So we go through multiple of these design cycles every year. So kind of the beginning of a cycle, I think, would be, you try to figure out what you want to achieve aerodynamically around the car. Then you try to figure out, okay, so if I have a theory of, if we do this, then this will give us performance, then you think about what geometries could achieve that. So then at that phase, you're kind of drawing up kind of surfaces and geometries in CAD. Then you do some simulation, so CFD, which is computational fluid dynamics. You use that to kind of simulate your ideas, and you iterate through that. And once you come up with a design that you're happy with, that then gets passed on to a design engineer, and then gets passed on to a lot of technicians, and it becomes a real part that we go and test in the wind tunnel. And during that phase of the process, I actually get to go to the wind tunnel and execute the test plan, working with our tunnel technicians and our model technicians. And the tunnel test is really kind of is this good or bad? It's the ultimate it's the ultimate test for your ideas. Then we close that loop with analyzing the wind tunnel data in conjunction with the CFD and try to figure out, okay, where do we go from here? What is our next theory? And then you kind of go through that cycle. Now, during the actual racing season, we get some like bursts of extra things during our day. So, on a Friday, we might be watching the free practice sessions while at work. We might be kind of browsing the internet, looking at competitor photos. And then on the Mondays after a race weekend, we do a team-wide debrief where they would kind of run through what happened over the weekend and go through a lot of the details. And if we won, we each get either a glass of orange juice or champagne to celebrate, which is great.
That's great. And if you're into teamwork, you get mimosas out of that. So that's fantastic.
Yeah, exactly.
I'm really enjoying this. The day in the life of Stephanie is quite curious to me too. I mean, I'm assuming you're not going up into space daily, but working with SpaceX, I bet you have some neat stuff that happens in a day.
Yeah, just really quick, and Hillary was talking, I wanted to ask, when you're doing your wind tunnel testing, do you do scale models or full scale or a combination?
Yeah, so these are all regulated by, I think, I guess by F1. So I've just looked it up. It's 180 kilometers an hour max speed. And per regulations, we have to run a 60% scale model. One of the challenges is the geometry scale and our top speed. We're not really able to match the Reynolds number for certain conditions. So that's one of the challenges we have with correlation between CFD tunnel and track.
Cool.
That's why they need you.
Yeah. Connect those dots. That's great. Unless there are any other questions, I want to hear about the day in the life. I'm just going to do a time check. We've got just a couple minutes left. So Stephanie, day in the life. We have 2 minutes left. So you take the time you need, and then we'll wrap up. This has been a lovely session. Go for it.
Yeah. So I don't know if I have a very typical day of every day. I would say that
it can be your favorite day.
A lot of days end up with a lot of design and review work. So because I worked as a spacecraft systems engineer, I would be basically kind of reviewing different pieces of the spacecraft from day to day, or different phases, operations, or different tests. A lot of either developing or reviewing test procedures, a lot of meetings, a lot of people just stopping by each other's desks, that kind of thing, lots of chatting. So there's, it's just a lot of just constantly taking in the new information, making sure that it's all going to still work at the spacecraft level, and seeing how changes will make that kind of trickle across the system, how they'll impact things. A lot of review of changes, risk assessments, that kind of thing. So
details.
That's probably enough. Yeah.
That's great. Fantastic. I mean, we're almost at the end of time. I just have one last question from the chat, and I feel like we can answer this as a yes, no for each of us. Have you ever met a race car driver? And I can answer no.
No.
Yes.
And Hillary, yes?
Yeah.
Stands to reason. Erica?
Yeah. On my first
not
day,
an F1 driver.
Oh, sorry. Go ahead, Hillary.
I was just gonna say, on my first day in the office, I met Lewis Hamilton, which is just, I was quite starstruck.
Awesome. Well, thank you so much, all three of you. That was a fantastic time together. I feel privileged, and I hope that our viewers enjoyed that, and our future viewers that may watch this later will also dive deep into these curiosities and learn a little bit from your experiences. I feel richer for having been in this session with you. Thank you so much. We are at time. I'd like to thank you all for joining us today, and a big thanks again on behalf of Science World, Girls in STEAM, for your time and sharing your experiences with us. Thank you so much also for you out there joining us today. Next up, we have our closing game show happening at the main stage screen, so be sure you head over there to participate. Thank you so much. I'm going to hang on tight with our panelists here and send all you off to your adventures next. See you later. Thanks, folks.
Bye.